Alright guys, welcome to this page of the notes, and what we're going to do here now, there's several different ways that I can ask you questions dealing with the composition of functions or composite functions, putting one function inside of another function. Again, lots of different ways that I can ask you these types of questions. And this is going to be one of them, and again, I apologize if you take a look in your notes. I wrote for each pair of functions. These aren't functions, or remember, a function is written in terms of a variable. What I've actually given you here, just cross functions out, these are actually relations. I apologize for that typo. Remember, a relation is a set of ordered pairs, right? Which is exactly what I've given you. I've given you a set of ordered pairs to represent the relation f, and a set of ordered pairs to represent the relation g. So this is the first way I could ask you to do composite functions or a composition of functions, and I want you to find f of g of x, which means we're going to plug g of x into f of x, and then we're going to do it the other way around, where I ask you to find g of f of x, or plug f of x into g. And of course that means if they exist, because it's possible that the composite function does not exist. And we'll take a look at that as we work our way through this example problem. And the last thing I ask you to do is state the domain and range, but we'll do that at the end once I've found all of my composite functions. Now, a couple of things here real quick as far as notation goes. You'll see me write these a couple of different ways. F of g of x, right? You're plugging g of x into f, can also be written like this. F. It looks like fog, right? But this is not an O. It's just a small open circle, which in math, the notation means of. So, f of g of x, right? Because my variable is going to be x. These mean the exact same thing. It's just two different ways, two different notations for saying the exact same thing. But please do not read this fog x. It's f of g of x. And what you're simply doing is taking g of x and plugging that into f of x. You work sort of from the left to the right. G of x goes into f of x, g of x inside of f of x. The other way to write it would be g of f of x, where we're going to plug f of x into the function g of x. And the other way of writing this is going to be g of f of x. Again, please do not read this goff. It is not g o f, right? This open circle in math, the notation means of. So this is the function g of f of x. And again, we work left to right, meaning f of x is going to get plugged into the function g. So that's really going to be the notation. I could write it. I'm going to write it both ways. You need to be comfortable. You need to be able to recognize both of them and know what they're asking you to do, which we'll get some practice with as we run through these example problems. So the first ones are going to be, we're going to start off with these f of x ones, right? These guys right here, f of g of x. So here's the way that this is going to work. Let me write all this out for you for the first couple until you get the hang of it. They're really not that tricky. It's just the notation that generally tends to throw kids off. So here's what we're going to do. We're going to plug g of x into the function f of x. But I've not given you functions. I've given you ordered pairs, which actually makes your job a lot easier. We're going to run through each of the ordered pairs given to you for g. We're going to plug each of those ordered pairs into the ordered pairs given to you for f. Here's the way it works. Remember, an ordered pair is x, y. The x is the domain value. The y is the range value. It's what you get when you plug the domain value into the function. So the first one I'm going to do, I have a domain value of 8. My x is an 8. So what I've done is I've plugged 8 into the function g. So f of g of 8. I'm going to plug in 8 into this function g. I haven't told you what g is. It doesn't really matter. Here's why. When you plug in 8 into g, I've told you that what comes out, the range value, is a 15. So when I plug in 8, my domain value, into the function g, what I get out is a 15. So I can then write this as f of 15. Now what I'm going to do, right, this g of 8, which is a 15, right? So what I've done is I've taken that smallest nesting doll, my domain value, 8. I've plugged it into my first function, right? Plugged it into the function, and what has come out is a 15. But remember, we don't stop there. I now take that value and plug it into another function. So now I'm going to take that 15 and plug it into f. Well, I need to find 15 up here in f, which I've got right there. There's my 15. When I plug a 15 into the function f, what do I get out? Well, the f function gives me back an 11. So f of 15 is 11. Why? Because I plug in a 15, I get out the range value of 11. So this whole thing is equal to 11. And again, just real quick, let me run through it again. I'm doing f of g of x. The first one, I'm starting with this force. We're going to work our way through all ordered pairs. I'm just starting with the first one. Nothing tricky here, nothing special. Starting with the first one. And why am I doing g? Because I got to do g first. I'm plugging g into f. When we go the other way around, I'll start with f. Right? I'll start with the ordered pairs in f, starting with the first one. So we'll do a 1 first. I'll figure out what that is and then plug that into g. That's when I do f, or when I plug f into g, or do g of f of x. So we're starting with, right, plugging g into f, and my first ordered pair, my first domain value is an x. So I'm going to do g of 8. When I plug in 8 into g, that function gives me a 15. So g of 8 is equal to 15. It tells me that right here. 15 is what I get out when I plug in an 8. Okay, so now we're going to take that 15, what I got by plugging 8 into g of x, and we're going to now plug that into the f of x. So 15 goes into f of x. What does the function give me back? Well, 15 was my domain value. That's what I'm plugging into f. The function f gives me back a range value, in this case an 11. So that's how I wind up with 11. And let's try the next one. Again, I'll write the first couple of these out so that you can see sort of how it works. Once you get used to it, right, we can skip writing all this extra stuff. All right, my next one, this is my next ordered pair. I'm going to plug in the domain value, which is a 5. So I'm going to do f of g of 5, right? I'm going to plug a 5 into the function g. Well, when I plug a 5 into the function g, what do I get out? Well, the function g gives me back a range value of 1. So g of 5 is equal to 1. So what am I now going to plug into my f function? Well, that 1. I'm going to plug that 1 now into f, right? So I take that 1, I plug it into f, and what does f give me back, right? I plug in a domain value of 1 into f. F's going to give me back a range value, which I get from my ordered pair. In this case, it's an 8. Let's do one more of these, writing it out the long way. I think you're probably starting to get the hang of it. You're starting to see what this looks like. My next ordered pair is this one. All right, so I'm going to plug in the domain value, which is a 10. F of g of 10. When I plug 10 into g, when I take that domain value and I plug it into g, what does g, the function g, give me back? Gives me back a range value, which in this case is 14. So g of 10, when I plug in a 10, it gives me back a 14. So f of 14. I'm now going to plug that 14 into f. Well, here's 14. I plug 14 into f. And what do I get back out? F gives me back a range value of 9. Awesome. All right, we've now done 3 of them this way. I think you're probably getting the hang of it. Let's do this one without writing all that stuff out. I'm going to do f of g of x. So that means I'm going to do f of g. The very last one I need to do is 9. All right, here we go. I plug in a 9, and g, the function g, gives me back a 0. Okay? That 0 is now going to get plugged into f. So I plug in the domain value of 0. I put 0 into f, and f gives me back a 13. All right. So there you go. That's the way that these are going to work when I give you a relation and I ask you to do f of g of x. You work inside out. Work from the inside of the composite function out when plugging in domain values. So you start with each of the ordered pairs for g because I have to evaluate g first. All right, plug in the x value, which the first one for us was an 8, just because that was the first ordered pair. I could have started somewhere else, but you work your way through them systematically so you don't forget any. So I just start with the first one. Plug in an 8. 8 plugged into g gives me back a 15. But then that's got to get plugged into f, right? Because it's f of g of x. Once I evaluate the domain value at g, I now need to take that and put it into the function f. That's why it's a composite function, right? We're taking our range value from g of x and plugging that in to get another function. So I take that 15 and I'm going to plug that into f. Well, when I plug in the value of 15, f gives me back an 11. Which is my final answer. All right, so here we go. They asked me to do the domain and range. So we're going to have our domain values and our range values. Remember, domain is what you plug in, range is what you get back. So let's look at what we plugged in. First, the first one, I started by plugging in an 8, a 5, a 10, and a 9, right? You can see that right here. I plugged in an 8, plugged in a 5, plugged in a 10, plugged in a 9. Those were my original domain values. So it was an 8, a 5, a 10, and a 9. Right? That's what I plugged in, and you know that. 8, 5, 10, and 9. Those were my original x values, my original domain values. That's what I started finding my composite function by plugging in. My original domain values, 8, 5, 10, and 9. Now, what came out as a result of the composite function? What was my final range value? Well, I plugged in an 8, worked all the way through it to get out an 11. So I have a range value of 11. Started with a domain value of 5. I work all the way through my composite function to get out a final range value of 8. I plugged in a domain value of 10. Worked all the way through my composite function to get out a final range value of 9. And the last one, I plugged in a domain value of 9, got out a final range value of 13, right? This is my domain and my range. And of course, if you wanted to, and again, I didn't ask you to do this, but you could just go ahead and map these guys. This is going all the way back to chapter 1, where we put these guys inside ovals. You go ahead and draw arrows from the domain to the range values. Right, we know that this is both a function that's one-to-one and onto, because each domain value goes to exactly one range value, and each range value corresponds with exactly one unique domain value. And you couldn't, I didn't ask you to map them, but you certainly could once you've got your domain and range. Okay, that's doing f of g of x. Let's go the other way. What if I ask you to do the composite function, which is g of f of x, where now I start with the relation f, and that's all going to get plugged into g. So let's go ahead and do that. I need to be able to see my function, so I'm going to go ahead and erase these guys. Erase, so that I don't have to. If I scrolled down to rewrite these guys, you wouldn't be able to see my original relation. One of the, disadvantages to the way I'm doing it. But here we go. We're now going to do these guys. g of f of x. So here we go. I'll write out the first couple. Actually, I'll write out the first one. I think hopefully at this point you probably have got the hang of it. So I'm just going to work my way through the ordered pairs in order. Nothing special here. I just do it in order so I don't forget anybody. And the first domain value, the first value of x that's going to get plugged into the function f is a 1. So I'm going to have g of f of 1. Now, when I plug a 1 into the function f, what's the range value I get back out? Well, I plug a 1 into f, and f gives me back a range value of 8. So g of 8, right? Because f of 1, when I plug a 1 into f, I get back an 8. But now I'm going to take that value and plug it into the function g. So I come down here to g, and I look for that initial value, that domain value of 8, which is right here. I'm going to plug that value into g and figure out what g gives me back. Well, I plug an 8 into g, and g gives me back the range value of 15. Sorry, that is a really ugly 5. Let me fix it. Get back a 15. Once again, hopefully at this point I think you guys got the hang of it. So let's go ahead and do a couple more here. We're going to do g of f of x. My next one is going to be g of f of 0, right? Because that's my next domain value. That's the next thing I'm going to plug in is a 0. So here we go. I plug a 0 into f. F gives me back a 13. I get out a 13. I come down to g. I have an 8, a 5, a 10, and a 9. I don't have a 13, and this goes back to when I told you that it is totally possible for a composite function to be undefined or it does not exist. And this is one of those cases where it is undefined. Right? I don't have an initial domain value of 13 for g. So if I were to plug a 13 into g, I don't know what I would get back because that's not one of my ordered pairs. So for these two sets of relations, it's undefined. It's undefined. Let's go ahead and do another one. F of 15 is going to be the next one. So g of f of x is going to be g of f of 15. Well, I plug a 15 into f. F gives me back an 11. So now I need to find an 11 in g. 8, 5, 10, 9. I don't have an 11 yet again. We have another one that is undefined. It just doesn't exist based on the relations that you've been given. Last one, g of f of x. The last one I need to plug in is going to be a 14. So f of 14. All right, well, I plug a 14 into f. F gives me back a 9. Great. I'm going to plug that 9 into g. Here it is. I plug that 9 into g. G gives me back a 0. And so my final range value is going to be a 0. I ask you to set up the domain and range. Let's go ahead and do that. My first domain value was a 1. The range value that I got by doing the composite function is a 15. The next domain value I plugged in was a 0. But when I plugged in a 0, I didn't get anything back. So we just leave that blank. The next one I plugged in was a 15, but I didn't get anything back for that one either. The last one I plugged in was a 14, and I got out a range value of 0. You could certainly write undefined over here if you wanted to. Again, remember, you could, if you wanted, map these guys out. I didn't ask you to, but you could map them out if you wanted to. So anyway, domain values, range values, they just come from looking at these two relations. I have another one of these for you on the next page, so go ahead, give it a try, and then come on back and see how it went, and I'll meet you on that page of the notes.